So this problem is dealing with a rectangular prism, and we know that the volume of a rectangular prism is given by length times width times height, and it is asking for the outer width and height. So first thing we should know is that the outer width is not part of the volume, so we need to specify based on the problem, the side and bottom should be 3 feet thick, which means the walls are all 3 feet all the way around, and the base as well. And we do know that the length should be twice the width and the height. So, which means if the width is x and the height is x and width is x, then the length would be 2x. But for the calculation of the volume, we cannot include the entire length, width, and height. So therefore, we need to limit our volume and set it equal to only the inner dimension. So right now we have the outer dimension is 2x by x by x. That would be the length, width, and height. But we need to know the inner dimension. So we need to set up the dimensions for that. Since we know the walls are 3 feet thick, so we need to subtract the walls at the end. So the length would be 2x minus 3 and 3 is 6 total. And the same thing for the width. Width is also 3 and 3 on each end, so that would be x minus 6. Now since the height, we don't include the roof, so we're only going to count the height as x minus the base is the one that has the thickness, so minus 3 only. We are not going to deduct anything for the top. So we have our new volume formula for the volume. So first thing we need to do is we need to zero out this left side. So we're going to blend in everything. But the first thing we need to do is undo all of this factoring. So we're going to FOIL the last two terms, since that seems to be a little simpler. So we're going to have x squared minus 3 minus 6 is a minus 9x total combined. And then the last term gives us a plus 18. And that was what we have for the second two terms. And then bring down the first term. We're going to need to superfoil the remaining to undo all of this factoring. So then we can combine the 972. So we're going to superfoil, so we have 2x cubed minus 18x squared plus 36x. And then the second set of terms will give us negative 6x squared plus 54x and minus 108. And then we need to bring down still the 972. And combining all of these terms on the right, I have 2x cubed minus 24x squared plus 90x minus 108. And we still have the 972. And now we're going to undo the 972 by subtracting 972 on both sides. And that will give us a zero balance on the left. And we can make this problem a little simpler by dividing by their common 2 factor in every single term. And we also need to do that on the left side of the equation. And that is not going to affect anything, so we'll still have 0 equals. You know what? I'm going to bring this down to a blank screen. So we will have 0 equals x cubed minus 12 x squared. Then we have 90 divided by 2 is 45x. And then finally we have 1080 divided by 2. That will give us a minus 540. And so that relates to the lesson for today, factoring by grouping. We have 4 terms, so we're going to do factor by grouping. And the common factor of GCF we have here is x squared, and we have x minus 12 left, plus factoring this, we have 45 in common, and we have x minus 12. And since the x minus 12 term is in common, we're going to factor out the GCF of x minus 12. That leaves us with x squared plus 45. And since this is a quadratic a polynomial equation that is set up equal to 0, we can solve for the zeros by setting x minus 12 equal to 0. So we have x equal to 12. And we will not be able to get any real zeros out of the second parentheses, because if you try to solve it by subtracting 45, you're going to have x squared equals negative 45. And you cannot take the square root of a negative number. So we're not going to get any real zeros out of that. So the only 0 we have is x equals 12. So going back to the problem, if x is equal to 12, then the dimensions would be, outer dimension would be 24 by 12 by 12. And that technically answers our question because it's asking you for the outer dimension. So outer dimension is 24 by 12 by 12. And it meets the criteria that if the height is 12 and the width is 12, then that makes the length 24. And so that would be the dimension. However, just to kind of put things in perspective here, the inner dimension is going to be 24 minus 6, which is 18, times 12 minus 6, which is 6, and then 12 minus 3, which is 9. If you multiply 18 times 6 times 9, that should give you the volume original of 972. So that tells us that the numbers work out. So that's the end of this problem.